In this video, we will explore rational exponents. A rational exponent is defined as the following. If a is a real number and n is a positive integer such that the principal nth root of a exists, then a to the 1 over n is defined as a to the 1 over n is equal to the nth root of a, where 1 over n is the rational exponent of a. Moreover, if m is a positive integer that has no common factor with n, then a to the m over n is equal to a to the 1 over n raised to the mth power, which is equal to the nth root of a raised to the m power. Additionally, a to the m over n is equal to a to the m to the 1 over nth power, or the nth root of a to the m power. Powers and indices. The numerator of a rational exponent denotes the power to which the base is raised, and the denominator notes the index or the root to be taken. For example, if we have b to the m over n, this is equal to the nth root of b raised to the m power, which is also equal to the nth root of b to the m power. Important to note here is that m is representing your power. So this is what we are raising the base to. N is your index. That's telling us what root we are taking. Let's look at some examples where we will be changing from radical to exponential form. In example A, we have the square root of 3. As 3 is just by itself, we know that we are raising 3 to the first power, and its index is 2. So the square root of 3 is 3 to the 1/2 power. In example B, we have the square root of 3xy raised to the 5th power. Remember that when we don't write our index, it is a 2. So this is going to be equal to the quantity 3xy raised to the 5 over 2, or the 5/2 power. Finally, we'll take a look here at a third example, and we will write this. This example is 2x times the 4th root of x cubed. Here we have two parts. Our first part is 2x. Our second part is the 4th root of x cubed. So first we will take 2x, and we know that we need to multiply that by x to the 3/4 power. Remember here that when we don't write an exponent, we assume that it is 1. So we can simplify this expression. So this becomes 2 times x to the 4/4 power, because that is the same thing as the first power, times x to the 3/4 power. We can then add these exponents because we're multiplying like bases. So we get as a final answer here 2x to the 7/4 power. We will now take a look at changing from exponential to radical form. So let's take a look at example A. Example A here says x squared plus y squared, and that quantity is going to be raised to the 3/2. And we don't need to simplify this here. What we need to do is just make sure that we write it in radical form. So remember, the 3 is our exponent, and the 2 is going to come outside of our radical. So we actually have the square root of x squared plus y squared cubed. Let's take a look at another example. Here we have 2y to the 3/4 power z to the 1/4 power. Note that the 2 is to the first power, so we can leave it by itself. Since our denominator of both of our exponential fractions is 4, we know that we are taking this to the 4th root. Y is being cubed. Z is to the first power. So we have 2 times the 4th root of y cubed z. Let's take a look at another example then. Here we have a to the negative 3/2 power. Note that to make this a positive exponent, it becomes 1 over a to the 3/2 power, which becomes 1 over the square root of a cubed. At this point, this is our answer. We've gotten from exponential form to radical form. We don't need to worry about simplifying this answer at this time. Let's take a look at one final example here. We have x to the 0.2 power. Note that you can write 0.2 as a fraction, and that is 1/5. So we have x to the 1/5 power, which in radical form is the 5th root of x. Let's take a look here at simplifying with rational exponents. So the first thing that we can do is take a look at example A. And example A says negative 32 raised to the negative 4/5 power. Remember here that your numerator of your fractional exponent is the power, and your denominator is the index. So here we can make this become the 5th root of negative 32. And it's okay, remember, to have negatives in the radicand of an odd index. And then we're going to raise this entire expression to the negative 4th power. The 5th root of negative 32 is negative 2, which we were raising then to the negative 4th power. So this becomes 1 over negative 2 to the positive 4th power, which simplifies finally to positive 1/16.